Hey guys, Dr. Emily here. I am super excited to talk to you today about bugs. All right. So just out of curiosity, have you guys ever seen a bug in the software that you've used? So I posted one in the Facebook group this past week. I was actually purchasing Microsoft Office and the web page came up and it had all of these variable names in it instead of actual text. Now, as a programmer, I can tell that this is a bug, right? And so I was just curious, have you seen bugs showing up in the software that you've been using? And if you have, just, let us know in the chat. I'd love to hear about it. And I mean, that's like the big picture bugs that we're trying to stop, right? Like we don't want to create those. But even more importantly is we really want to work on the bugs that we get in our own coding. So if you've ever tried to code yourself, and have you ever had the situation happen where you sat down, you tried to type something in, and then it didn't do what you're thinking? Has anyone ever experienced that? Where you typed a piece of code and then you went to run it and it didn't do what you're thinking? If that's you, feel free to, give us a like, pop a note in the chat. We'd love to hear about it. But that's the situation today that we're going to dive into and give you the professional tricks so that you don't get frustrated. So you don't have to sit there banging your head against the wall for hours and hours and hours. Been there, done that, not cool, right? So what we want to do is find a systematic process where we can actually figure out where the bug is and fix it and solve it. And so we are so going to talk about that today. I'm super excited to share that with you. And one of the things I want to just briefly mention is the purpose of bugs in our development life. Because one of the challenges I find with bugs, I know before I understood this 5-step process for debugging anything, I would get so frustrated by the bugs that I would come across. I would just get mad, like, why won't this work? And I get frustrated. And the challenge is that being frustrated and mad isn't going to help me solve the bug, right? It's not going to help me perform at my highest level. Why is this important? Well, if you want to learn the fast way, right? Like inside the Joy of Coding, we are all about working smarter, not harder. It's all about finding the path to learn how to code fast, as quickly as makes sense for us. And so the fastest path that I've found with all my years of teaching, I was a professor for 10 years, teaching these software engineering skills. And what I've seen is that the fastest path is to learn by doing, right? So we want to learn how to code by doing it. And when we learn to code by doing it in that hands-on experiential way, we are going to come up with bugs. So what purpose do bugs serve? Because actually they can be really helpful despite the fact that they're so frustrating, right? So bugs are helpful because they actually are our guideposts to know how to learn and to keep growing and learning. Because the thinking, like let's say we have a bug that we created. The thinking that we had that created the bug is not the thinking we're going to need to have to fix it. So a bug is actually calling us to learn, grow, and level up our thinking so that we can get there. And sometimes it helps us to ask for help, right, of someone else who might already be there, and they can help guide us over that hurdle, right? And so if you're interested in support on that, please, reach out to me. We can totally talk about the Joy of Coding Academy. But today our focus is on debugging itself. So one of the ways that we can actually help ourselves do a better job with debugging is to not get frustrated with the process, but embrace it and know that this is how we improve ourselves, how we grow and how we learn and how we become that 6-figure software developer as quickly as possible. I am going to dive into some actual tactical techniques today, so no worries. But if you can try and keep that bigger picture framing of, okay, this is a bug, it's an opportunity to grow and learn, right? You put that positive spin on it, already you're going to be so far ahead of the game in terms of fixing it. So keeping our mindset positive will really go a huge way towards helping us level up and fix the bug in a calm way, right? Okay, so then you're starting off on the right foot right off the bat. Love it. Okay, so what debugging, right? I've promised you today, and we are going to dive into that right now, a 5-step process that you can use to debug anything. And I use this process all the time. And in fact, these steps are steps that other developers do naturally and intuitively. This is something that I actually invested many years of my life as a PhD student learning how to understand code and debug it effectively. And in fact, I got so good at it. It used to take me like weeks to do this, and now I can do it in a few minutes. And so that's why I'm going to share this process with you, and trust the process and keep doing it and applying it, and it will get faster, right? Like the first time I figured this out, it took me a week. And then I started every week, I would do it again and again and again until it takes me now 20 minutes. So you can absolutely rock this out of the park. So there's a couple different types of debugging, right? So when we encounter a problem in our code, we have a couple tools that we can use to kind of dive in and try and understand what's happening. Because at the end of the day, we need to understand what's happening. Bugs happen because we assume that our code and the way the coding system we're in works is one way, and it's actually another. So somewhere there's a gap, there's a disconnect between what we assume intuitively is happening and what is actually happening in reality. So we have to find that gap. So we have to understand what's happening. If we can't understand what's happening, we can't actually find the gap and then bridge it, right? So we have to understand precisely what's happening. So what are the tools that we can use to do that? And again, if you guys have questions or thoughts, like please share them in the comments. I'd love to hear them. So the first step is that we want to pick the type of debugging that we're going to be doing. We can do a couple things. We can add print statements. Has anyone ever added a print statement in their program to try and understand what it's doing? I hope so. I see some students in the room. So I'm hoping you guys have been doing that for sure. And then we also can use an automated debugger. That's a more advanced skill, you know, when you're in it and you're really, you know, starting to deal with programs that are big. Yes, Arthur, all the time. Love it. So when your code is really, really big. So what would be big? More than one file. If you start working with codes that are multiple files, you probably want to start thinking about transitioning to automated debugging tools. And then we also have, if you're, you know, before you get to the print statements, what you may find is useful is actually manual debugging. And I do this even when I have a really big system, because I usually only have to understand this for a small piece of it. But the advantage, especially when you're early on in your coding career and you're just getting started, manual, what's called a manual walkthrough. What is it? It's where you look at a piece of code and you walk through it line by line and predict what it's going to output. This is so helpful because this really helps you, it helps you practice your skills and your 7 basics and make sure you're rock solid on everything. And it also helps dive in and figure out exactly where the problem is. So it's going to be really, really helpful there. So that's one place you can start, right? So there's all these different ways that you can do the debugging itself. So now I'd like to talk a little bit more about those steps. Like, what are these 5 key steps that we can follow to figure out how to debug? So the first step is we have to actually be able to replicate the bug. So if you've got an error and you can't replicate it consistently, okay, these steps aren't going to work very well for that. That's going to take some pro level digging deep and diving into, because you need to be able to replicate it. There are sometimes bugs, especially in software that has randomization to it or engages with a wide variety of complex systems. There are cases where you may not be able to replicate the bug. And so that this technique might not work there, right? You want to use a different set. Or if you can, ask someone with more experience because they might be able to replicate it, right? Because once you can replicate it, you're halfway there for understanding it and fixing it if you're replicating it. And once you've replicated the bug, your job as a developer is not just to run the bug repeatedly, but to minimize. What's the minimal input or the minimal sequence of steps to replicate that bug? Right? Like, how do we make it happen? Does it happen like, let's say there's like a divide by 0 error. It works on your computer. Awesome, Eric. Love it. So, you know, if there's a divide by 0 error, right? So does it happen with every input? Only some sets of the input? Like, how often does it happen in what situation? So it's not just about replicating the bug, but doing that due diligence of really exploring that input space to see like, okay, well, it doesn't matter if I do this step first, but then, okay, if I do this, no matter what comes in, if I do this thing, I get the bug. So then you've isolated it, right? You've reduced it. And so you really want to focus on that, because this is going to make your work less later on. You're going to spend less time understanding it and fixing the bug. And to be honest, what might surprise you is that when people go into debugging and, you know, improving an existing software system, a full 80% of the time, like let's say it takes you 2 hours to debug something, 80% of that time, so what is that, a little over an hour and a half, is spent understanding. So the more work you do figuring out how to isolate and replicate that bug, it's going to cut down on that understanding time, because you don't have to understand as much code when you've isolated exactly what's causing the problem, right? So these are all really necessary steps that you don't want to skip, right? Because it's super impactful in helping you streamline and make your debugging process more efficient, because six-figure software developers are efficient. That's why they get paid the big bucks. They keep investing in themselves and getting more and more efficient. So we want to do that too. Awesome. So once we've replicated the bug and we have that minimal input that triggers it, that causes the bug, like we know exactly what does it, we know what doesn't cause it, at that point, your work might be done, right? Believe it or not. Believe it or not, the process of isolating the bug and figuring out what the minimal trigger is for it can actually sometimes lead to the epiphany of the bug itself. All right, so that's awesome. Win, fix it, pat yourself on the back, woohoo, you're done. Okay, if it's not obvious, because sometimes we get bugs, they're challenging. Yes, I've definitely been up late overnight, banging my head against the wall. I won't lie, it happens. Bugs happen. So if the fix is not obvious, what's our next step, right? So one of the things we want to do is now step through the code, assuming that we've isolated the bug in a minimal way, like we know how to trigger it minimally. That's going to consolidate and condense the amount of code we need to look at. So what we want to do next is walk through that code, because we are looking for the point at which our assumptions of what's happening do not align with reality, right? So we have a hypothesis. Okay, I think that the code works like this. Somewhere, one of those steps that we're thinking is not true. Otherwise, the bug wouldn't be here, right? By its very nature. So we want to find, okay, where is that point in the code that our understanding does not align with reality? And the way we do that is by stepping through the execution. And we cannot do that without actually going through it step by step. That's a deal. You have to be able to do that. Oh my goodness, one of these things is not like the others. Yes, love it. For sure, right? And so those types of debugging that I mentioned at the beginning of the live, we had manual walkthroughs. And to be honest, I still use that for code sometimes. If I really have a bug that I'm just I can't get it, I print it out and I go sit somewhere separate from my computer and I sit down and I walk through it. That's really good when you're in the beginning stages and you've got small programs. Even if they're 1 or 2 files, what I find is that changing my space and my situation, getting away from the computer, actually helps me think better, right? Because it's taking me out of the space. I'm not as likely to just sit there editing it and doing trial and error for hours and hours and hours on end, which is not going to be helpful in this case. So by printing it, I'm committing to doing the thinking work of thinking it through. And so I'll go and I'll sit in a chair away from my computer and I'll literally write down what each variable value is, what memory looks like, and figure this out. Exactly, step by step. Exactly. So that's one way to do it. And when you're early on in your career, you're just getting started, you're mastering those 7 basics still, you're still learning about loops and functions, this is the perfect way to do it, right? I really highly recommend that. Once you're a little more familiar, you can also use print statements, especially if the code is more complex or if it's getting more than 20 lines of code. Let's say you need to understand 100 lines of code. Printing can really help, because what you can do, now you have to make sure that with the printing and the manual walkthrough that you are predicting the output before you look at the computer's answer. This is not skim the computer's output, because what you're looking for, you are a detective. And your job is to figure out where your understanding doesn't align with reality. And the only way you can do that is by actually writing down what you think each line is going to do, what you think is going to happen, so you can find that gap with reality of what's actually happening, right? So we're on the hunt for that. We're looking for that. So that's one of the tips about manual walkthroughs, or adding print statements to help, draw your attention to it, or using an automated debugger. So that's a more advanced technique. If you've been around the block, learning to code for a while, using an automated debugger, most development environments or IDEs provide a way for you to step through line by line what's happening in the code and actually look at the variables that are in memory. So it's kind of like the next level up from prints. Prints will get you there a little bit, but automated debugging is an amazing tool, and it's a true skill to learn how to use it. So once you walk through that code, at some point, it should either you will fully understand the code and recognize what's missing, because sometimes the code that you need to fix it isn't there at all. Or you're going to have found a point in the code at which you're predicting the output and it's different from what's actually happening. So now you've isolated your bug, right? You've figured out where it is in the code. And so once you now have that full understanding of what's going on, you should be able to spot the bug and suggest a fix. And if you haven't, then you're going to want to keep digging in and see, you know, what's not clear. At some point, like, you will find a place in the code where your understanding does not align with reality, and you just have to kind of trace it back as a detective. Once you kind of have an understanding of that code and where the bug fix should go, you make the fix and then rerun how you replicated the bug in the first place. And that's known as testing, right? So when you run the code for the purposes of checking its correctness. So whatever sequence of steps we use to expose the bug, we want to rerun them and confirm that it still works. Ideally, we also probably want to rerun some other basic test cases and just kind of run things a little bit so that we can actually see that when we made the fix, we didn't break anything that was already working. That's called regression testing. If you're if you're looking for those buzzwords to put on your resume and to include in your interview prep, for sure. All right, so that's the 5 steps where we craft, and just to review that, we craft the input that exposes the bug, we replicate the bug, and then we refine it to be minimal as possible to cause the bug to happen, right? And that's half the work right there, is just crafting the input that's minimal that makes it happen, because that severely restricts where we have to look in the code. It's super optimal, because the most expensive part of the debugging process is understanding the code. That is always the most expensive and time-consuming step that we take. So the more we can hone that down and reduce that, it's a huge win on our efficiency. And remember, this difference between a 6-figure software developer and up and those that are not yet at that level is efficiency, right? It is their ability to solve bigger problems more quickly. And once we refine the input to be minimal, most of the time, the fix is obvious. If it's not obvious yet, because sometimes there's also missing code. Those are kind of challenging bugs because we have to figure out what's missing. But at some point, we're going to step through that execution using either manual walkthroughs, print statements, or an automated debugger, and we're going to find where our understanding of what's happening does not align with reality. That's the goal. And so we want to predict that, right? We don't want to get lazy about this and just look at what the computer said and say, okay, it's good. No, right? Like you want to predict it first, then check it. And then once you've done that, you should understand the code fully enough that you can spot the bug and make the fix correctly, and then you test it. Imagine if bugs were a thing of the past. They're never going to be a thing of the past, but what if they weren't quite so heavy? And they weren't quite so big and time-consuming and show-stopping, right? Imagine that this process worked for you every single time, and it can. So my challenge to you today is to try this out, is to go home in your own coding and try it and see how it works for you. And then keep practicing it. Get that confidence in your ability, because that's going to be the difference that comes across on the interviews that helps you land that first job, right? Is really that confidence in your ability to walk into any situation and make something happen and move it forward. So you can really, really make your development a breeze. Now, one of the things I did also promise in today's live to leave you with, and we have just a couple minutes. So if you have questions, please post them there. Ooh, thank you, Arthur. Predict, check, understanding, and repeat. Love it. So good. If you have questions, please don't hesitate to type them in here. I'm gonna leave us with one final idea moving forward, because debugging is an immensely powerful skill. Like, all professional developers have honed their ability to debug. You just can't live without it, right? It's just a fact of life that you're going to face a bug. But at least it doesn't have to be stressful, right? And even though you don't know the answer, you know that you can get it, right? It's kind of like if you're a farmer, you might not have the milk, but you have a cow and you know how you can get it. So the cow is like the debugging process that you have confidence in. Like, okay, I don't have milk right now, but I can go get it. Think of that superpower. How would that feel to you as a developer to have that ability, right? Like, you'd be ready to take on the world. So it's super, super impactful, super powerful. But the other flip side of this is, what if we didn't have to have bugs almost at all? Or could we even shrink and reduce that debugging process even further to be even more efficient? Ooh, can I give an example of a bug I solved using this process? I love this question. I love this question. Oh, like every bug I've ever done. So let me think. All right, I'm going to think of one, Arthur. Keep going. So good. I'm trying to think of one that'd be meaningful to a broad context, because what I've done is I will just take a random system and there'll be a bug in it and I will apply this process. Like I will literally, and I've created actual activities. So if you're interested in that, and Arthur, you have access to these, by the way, I've created actual activities that I turn around and give my students to help them hone their debugging skills. And I've done when I was a professor, I would do a practical exam where I would have a test case that was failing and then have it pass. What sticks out in my mind are the ones that this didn't work for because the bugs were too big. They were bigger. We weren't following a honed enough process for these to not exist. And so that's the flip side that we want to get to. That's really the flip side that we want to get to. I do have a bug that this was never going to work for. Not necessarily helpful, right? So the bugs that stick out in my mind are the showstoppers where this didn't work because I use this now. And so most bugs, they're easy. It's the ones that weren't easy that stick out in my mind, or like where they're impossible to solve. That was my favorite. Spent 3 days implementing something that was impossible to code up. It wasn't solvable. So that wasn't going to work. But yes, I've spent time doing there too. Yeah. But every time, I mean, I guess a couple things that I've used this for, now that I'm kind of thinking about it, we had a bug in the web system where one line of code, it was inside an if and it was causing a bug and we had to move it outside the if, right? And so I had to isolate that line was the problem. That's what was missing. I've had situations where I've had to sit down and I looked at a code, it was a front end issue, and I had to go through and figure out, okay, where is it going wrong? Where is it not doing what I expect? So to be honest, this process is something I internalize and do just all the time, daily. Like every time I code, I can't turn it off. Like it's just the process that I follow. If you feel you're stressed, sign to step out. Yes, exactly. Go for a walk, get a break. Absolutely. Right? Just change your state, change your situation. And that's one of the reasons why a manual walkthrough, the low tech, can be super helpful, because it gets you away from your computer, what you normally do, how you normally engage. So it helps your mind think through different pathways, right? So it's super cool. But one of the things I want to leave you guys with, these are awesome questions. So keep them coming. I love it. Great comments, great suggestions. I love this. One of the things I want to talk about just to leave you with is, well, is there a way that we can actually debug less? Right? Can we actually set things up in advance? Can we change how we develop, how we build programs so that we don't have to follow these 5 steps, right? Or we still need to use these 5 steps, but so that it's simpler. So we're not having to understand code all over the code base. And the way we do that is there's a very, very simple technique, and it takes discipline to do it, right? Test your code, Pedro. You got it. You've got it. But it's not just testing our code. It's also when, right? When do we test our code? And so I know a lot of people, especially in the beginning, will sit down, will type up a whole 100-line program and then hit run. There's a bug. Where's the bug? I just wrote a 100-line program. Where's the bug? I don't know. One of those 100 lines is wrong. Maybe 2. Maybe there's a couple, right? So it's not just about testing our code, but when do we test our code? And the ideal, optimal way to test our code is basically every time we change it. The smaller the changes that we can run, the faster the debugging is going to be. Imagine I had a 10-line program, it's tested, it runs, and I add one more line and there's a bug. Right? When I run it, it doesn't give me the output I expect. Where's that bug going to be? It's going to be in that 11th line that I just added. Do I have to look over all the lines? No, I just look at that one line right there. That's all I have to look at. So there's not that much, it's not that big a search problem, right? Like it's just this one line that I added. And so great, test and repeat. Exactly, Arthur. And we just want to shrink that loop to be as small as possible. Now, there are limits. You can't write a character and test it because your code won't compile, right? So we do want to actually make changes to our code, but we want to make them as small as possible. And the best developers make tiny changes and then run them. right? So you want it when you're thinking through your problem, actually one of the challenges that you may come across is, okay, how small a step can I take forward so that I can test it and run it? Like the professional developers I know are always thinking in the back of their mind, how can I test it? How can I test it? How can I test to make sure this is working correctly? Because they just know we're going to make mistakes. We're not going to know everything. It's just a fact of life. It's why we're here. So we have to just assume that we're going to make a mistake and set up our process so that fixing it is as easy as possible. It doesn't take us hours. We don't have to understand hundreds of lines of code. We have one tiny place, right? And then if it's that one tiny place, here's what can happen. Even one line of code that looks correct. Maybe you Googled it and someone else suggested this was the line of code you needed to add to have this feature the way you wanted it. Well, what can happen is modern software systems interact with a ton of libraries. And so the variable that you might not know is, how does the code that you write interact with the rest of the world of software that's out there? So you might build in a web system, for example, if you're a front-end web developer. How does the line of code you write interact with the web browser, with the framework that's rendering it, if you're using React or Angular or Node or whatever you're using? Like, how does that one line of code interact? And so the more we can isolate the code that we write and run it and test it and verify it, that's going to tell us and guide us where we're learning next. So let's say we run one line of code and we've even tested it in other contexts and we know, oh, I've used this before, it works. Why isn't it working today? Well, it's probably interacting in the web system in a new way that you haven't experienced before. And so now you have an invitation to deepen your understanding of that web system and how it interacts, right? And so this is how we drive our learning. This is how we learn quickly and we level up as a software developer. All right, awesome. But yeah, it comes down to running your code all the time and not just like glancing at the app and be like, oh yeah, it's good. No. When I say run your code and test it, I mean predict what you expect it to do before you run it. That's the discipline. There's 2 steps of discipline in this process. One is creating minimal changes and running them. And before you look at the output, predicting what you think will happen, right? Those are the 2 key steps. You do those 2 things, your development life, it's going to be a breeze. It's going to be a game changer for you. All right. Awesome. You guys are great. Thank you so much for your questions and comments. This is so good. If you have any other questions or comments, please don't hesitate to put them in the comments on Facebook, and we're happy to answer them and get that conversation going. So wherever you are in your journey, good luck. You've got this. Debugs can totally be a thing of the past with this awesome professional 5-step process for knocking that out of the park. And if you would like support on your journey to learning to code, reach out. Dr. Emily, I run Joy of Coding Academy, where we give hands-on support to our students every week on mastering things like this 5-step debugging process to really take them up to the next level and become 6-figure software developers faster. All right. So keep on learning, keep on coding. Have an awesome day, and I'll see you soon. Take care, guys.